All right, let's have some fun looking at certain equations and seeing how we can solve for the mysterious unknown thing. Okay, so let's take a look at a very simple example first. We've got 3t plus 4 equals 5, and we want to solve for t. Okay, well, this is not a big deal. We know what to do. We want to, we have the plus 4, so we want to undo that. And we do that by subtracting 4 from both sides, of course, to keep this fair and balanced. And when I do that, I see 3t, of course, that remains. And then I have a 4 minus 4, which is 0, which is exactly the point, of course, right? The idea is to actually have that drop out. So we simplify our lives. Then I have 5 minus 4, which is just 1. And now what I want to do is I want to get t alone. So I see 3t. So I want to undo the multiplication. I'll just divide by 3. And so on the left-hand side, I'm just left with t. And on the right-hand side, I'm left with a third. And that's the answer. So the unknown here is t equals 1/3. But, you can actually look at a related equation, which is kind of interesting. So here's the related equation. It's not the same equation. 3t plus 4z equals 5. Now, here we're not just going to be able to figure out exactly what t is. If you want to solve for t, we can, but it's now going to be in terms of z, because this is actually an equation that has two unknowns. And so these are now variables. We can think of them as variables, and now we can solve for that variable if we want. It's variable in the sense that it will vary as the value of z varies. Here, it was just an unknown. It was a value. In this case, we found it to be a third. It's now known. So here we have an unknown, and now these become variables. So let's now solve this for t and see that it's going to correspond quite nicely with our previous work. So if we do this, we start off with, so actually, let me just make sure that I'm going to put a big bar here. Big bar. Here we go. There we go. Great. Now, we start off with 3t plus 4z equals 5. And if the mission is to solve for t, if that's what someone asks us to do, then I want to isolate the t. So the first thing I want to do is get rid of this term, which has no t in it at all. And the way I will do that is by, well, I see it's being added, so I'm now going to subtract it off. So if I subtract off, I take off minus 4z equals minus 4z. If I do it to one side, I got to do it to the other side. And now, when I subtract, I still have the 3t, and now 4z minus 4z is 0, which is exactly as we designed, and that's going to equal what? Well, now I have, so remember before I had 5 minus 4 and I got a 1? Well, here I've got z's in it, and that's just kind of hanging out there. I can't combine it. I could just combine it. I could just write 5 minus 4z. And that's the best I can do. I can't combine them any further since z is a variable. Now, I want to solve for t, so I want to get t by itself, which means I should divide both sides by the 3 that's multiplying the t. And what I'm left with is, well, 3t over 3 is just t. And on the right-hand side, I see 5 minus 4z all divided by 3. And that's the answer. Now, how do these relate? Well, notice that if I let z equal 1, if I put in 1 for z, then if I put in 1 for z, this is just 4. 5 minus 4 is 1. 1/3, I get this answer. So in some sense, this is a generalization of the previous equation. Kind of cool, huh? I love this stuff. This is great. How much fun is this? Okay, now, you can do lots of interesting things. For example, suppose that you had this relationship that p times v equals r times s times t. Now, suppose that someone came along and said, you know what, I'd like to know what t is. Can you solve for t? Well, on the one hand, you could say, okay, this is kind of like a two-step process, because I first have to get rid of the multiplication by r, divide both sides by r, then get rid of the multiplication by s, divide both sides by s, and I get the answer. But I could also realize that if I just think of the variables r and s as one collective thing, I could just divide both sides by r and s and make this a one-step equation. Let's try that. So if I start off with PV equals RST, if I want to undo the multiplication by RS, the product of those two things, I'll just divide both sides by RS. You could divide by R, then divide by S, do it a la carte, and then you actually have a two-step equation, but magically I'm going to do it as a one-step equation because now when I divide by RS, I'm just left with T on the right, and on the left, I'm left with PV over RS. And that's the answer. That's what T equals. If you like to write it the other way, T equals, that's fine. T equals PV over RS. Doesn't make a difference how you look at it. It turns out you can get the same solution. So again, if you have lots of variables running around, you can always isolate one if you want to and solve in terms of the others, which is kind of cool. All right, now I want us to take a look at an application where this is actually used in practice every day, especially if you travel from the US to Canada or other places where they actually use Celsius. So if you want to take your temperature, are you feeling sick? You can never feel sick doing math, but if you were doing some other subject, maybe you get a little ill. You want to take your temperature. Well, are you going to do it in Fahrenheit? Are you going to do it in Celsius? Aha! I got you. Let's check it out. Now, the formula for converting Celsius and Fahrenheit is given by this. C equals 5/9 times the quantity, the Fahrenheit degrees minus 32. Or C equals 5/9 times the quantity, F minus 32. And that gives us the conversion to Celsius temperature in terms of Fahrenheit temperature. And now our mission, should you choose to accept it, is to convert 100 degrees centigrade, negative 20 degrees, Celsius, negative 20 degrees Celsius, and negative 5 degrees Celsius to Fahrenheit. Now, if you look at that formula, what you notice is that we're given Celsius degrees as a function of Fahrenheit. And so what we want to do is we want to convert to Fahrenheit, so we have to solve for F. So here's an example, just like the ones we saw recently, where we want to actually take this equation and solve for the variable F. Write this in terms of C. So how do we do that? Well, we know how to do that. The first thing I want to do is undo the multiplication by 5/9, which means I'd multiply both sides by 9/5. So if I multiply both sides by 9/5, what do I see? I see 9/5 C equals F minus 32. So now what do I want to do? What I want to do is solve for F. So I should add to both sides 32 to undo the subtraction. Both sides to keep everything fair and balanced. Now on the right-hand side, that's kind of easy. I'm just left with F plus 0. Now here, you can't combine these because there's a C here. There's that variable, and this is a number, 32. So all I can write is 9/5 C plus 32. And that allows us to go from Celsius to Fahrenheit. And now I've got the formula I want. Now using this formula, I can now convert. So let's convert the ones that were asked. So the first one we asked was 100 degrees Celsius. So 100 degrees Celsius. Well, how would we proceed? Well, here's the formula. F equals 9/5 times whatever we want to put in here in terms of Celsius plus 32. In this case, we want to pop in 100 degrees. Now that's hot, so I'm going to use red. And so I see 9/5 times 100, which equals, well, 100 divided by 5 is just 20. So I see 9 times 20 plus 32, which equals 180. We do the multiplication first. Plus 32, which equals 212 degrees Fahrenheit. Hot stuff. So 100 degrees Celsius is equal to 212 degrees Fahrenheit. We made that conversion by taking a look at this particular formula, which gives us those two variables and their connection, and plugged in one variable, one quantity for one variable, and saw what was left for the other. Now, if you want negative 20 degrees Celsius, that's going to be a little bit colder, so I'm going to use blue, of course. So I put a negative 20 in for the C value. And I've got to now multiply that by 9/5. Well, negative 20 divided by 5 is actually negative 4. So this equals 9 times negative 4 plus 32. And 9 times negative 4 is negative 36 plus 32. And negative 36 plus 32 is negative 4 degrees Fahrenheit. And there you have it. Pretty cool. So let's try one.